Hello, welcome to Basic Electronic Theory. In this video we will be talking about electric current and voltage. In this video and future videos I will not be touching on detailed physics. As for you, I would like to show you how to apply theory straight into practice for a more hands-on approach to electronics, though still some theory must be known first. So let's begin with electric current. Electric current I is the total charge that passes through a cross-sectional area. As shown here, delta Q is the amount of charge passing through a given area, shown here, and delta T is the time interval for a charge to pass through an area. So the time it takes for a charge to pass through this area. Using these, we get the formula I, electric current, equals delta Q, the charge, the amount of charge passing through a given area, over delta T, the time interval for a charge to pass through an area. To easily remember this, we can make this triangle. So Ri goes here, delta Q goes here, delta T goes right here. This is how we will easily remember it. What's the unit of current, you might ask? Well, to answer that, it is coulombs per second. So it is coulombs per second. However, the SI unit of current is the ampere. So these are the same. Do not get confused. So 1 ampere equals 1 coulomb per second. How is this useful to us, you might ask? Well, let's do a simple question. So let us say you would like to find the current for when a car battery sets off in motion. It gives 500 coulombs of charge in 5 seconds. So we can easily do this by using our newfound equation. Let's do our triangle. Delta Q, delta T. We have our charge, delta Q, and our time, 5 seconds. Just substitute this into our equation. We get, quick mental arithmetic, we get 100 amps. So how does electric current flow then, you might ask? We will need you to understand some things first. Firstly, electrons are negatively charged particles, and they are attracted to positively charged particles, which are protons. Conventional current is the flow from positive to negative, and electron flow is the flow from negative to positive. So, what has caused this? Well, Benjamin Franklin had said that it was positive charges, the protons, that moved. It was later discovered by Joseph Thomas that it was actually negative charges that moved the electrons. So I've drawn out this simple circuit here. We have our power source, our battery, our wire, and our LED. This is the symbol for an LED, just so you're aware. What is happening is that these electrons within our wire, our conductor made of copper, they are roaming around randomly, but they'll need a little bit of push to get there. This is where our power source comes in and supplies voltage. So, for an electric current to flow, a voltage must exist between 2 points. If we take a power source, for example, it could be a battery, the electrons move from the negative terminal to the positive terminal, and this is how circuits are formed. And this right here, so just drawn out, is a closed circuit. Now I'll show you what will happen if we put an LED. So we'll use a real life LED example. I have my power cables. This is my LED. I'm going to connect the positive and the negative. I'll turn this on. And as you can see, the LED, the light emitting diode, has lit up because we have a complete circuit. Electronic circuits usually use conventional currents, and because of this, we use the symbol I to represent this as mentioned before. So just so you remember, conventional current is the flow from positive to negative, and electron flow is the flow from negative to positive. So in our live demonstration just before, where we had 5 volts being applied, if we disconnect one of these leads, our LED turns off. This is because we have an incomplete circuit, but when we connect it again, we have a complete circuit. Incomplete, complete. As mentioned before, the voltage drives electrons, and so voltage placed across a conductor give rise to something called Electromotive Force EMF, which gives all the 3 electrons a push within the conductor from the negative to positive terminal or leads. So let's draw this out. We have our minus here, positive here. So we have our electrons going around here. So what's happening within our circuit is that we're going to give this little bit, we'll apply a voltage, and this is going to cause the electrons to repel. So this one is going to repel here, that's going to bump to that electron, and that's going to bump into this electron, and that's going to bump into this electron, and that's essentially what's happening in between in our circuit. This voltage acts as an external influence and causes it to repel a nearby electron, and this electron repels it to its neighbor electron, and this chain reaction goes on. Just so you know, in the realm of electricity we have something called direct current, DC, and alternating current, AC. So, direct current, DC, alternating current, AC. DC is a steady flow of electrons in one direction, well, just like our power source here, the battery. So what would happen is that for direct current, if I draw this out here, we just get a steady flow. However, for AC, it is the fluctuating flow of electrons that keep changing directions. So if we draw it out here, you would get something like that. An example of this would be your home electricity sockets. They are AC. So going back to our LED here, I'm driving this LED using 5 volts. What would happen if I increase the voltage? The LED will take up as much current as it needs from the power supply. So I've got a 5 volts here, it's drawing about 180 milliamps. So we're going to steadily increase this. 5 volts, 6 volts, 7 volts, oh it's a bit dim. 8 volts, 9 volts, 11 volts. As you can see, though it's flickering a bit still, though it's dead. As you would find, electronic components and appliances in general have a rated voltage and current, and for this LED here, we've gone past its rated values. So please do keep in mind when you deal with these. It would be good to know them. Thank you for watching. That was a quick video on electric current and voltage. The next video will be covering resistance.